Hello and welcome to step 10 in geometry, where we're going to talk about all things dilations. So these are kind of similar to the transformations we've already talked about in unit 2, but they're going to be slightly different. So in our translation, rotation, and reflection, our beginning pre-image and our final image, no matter if we were doing one or two transformations, the size and shape of the figure stayed the same, right? They were congruent from the beginning to the end. In a dilation, the shape is going to stay the same look, but the size is actually going to get bigger or get smaller, okay? And we know how this is going to move based on what we call a scale factor, okay? And the scale factor is always going to be used with the letter K. Okay, so if K, or the scale factor, is greater than 1, okay, the image is going to get bigger, and this is going to be called an enlargement. Okay, the reason that is because when we use our scale factor, we multiply with the scale factor. So if we multiply anything by a number bigger than 1, it's going to increase the number and get bigger. So if the scale factor is between 0 and 1, the image is going to get smaller, and we call this a reduction. Okay, so it's going to get smaller. Okay, so sometimes, a lot of times our scale factors are just nice whole numbers, which is super nice. Sometimes they're fractions. So if you have a fraction, you have to decide, is it a fraction bigger than 1 or smaller than 1? And we know that by if the numerator, the top, is bigger or smaller than the bottom or the denominator. So something like, like 3/2 or 4/3 or I don't know, 7/5. Do you see how the top is bigger than the bottom? That means that all of these fractions are going to be bigger than 1 because they're improper fractions. Okay, but fractions like 3/4 or 1/5 or I don't know, 2/7, those are all smaller than 1, so we know it's going to cause a scale factor. Worst comes to worst, if you're not sure, feel free to type the fraction in your calculator, right? We could type 3 divided by 2, we would get 1.5, and we could see, oh, that's bigger than 1, so it's going to cause an enlargement for us. Okay? But there's one special case. What happens if the scale factor is just 1? So think about if we took any number and we multiplied it by 1, it would stay the same. So if all of the sides or the points are going to stay the exact same, then these two images are going to be congruent to each other. Okay? All right, so just a couple examples of where you have seen dilation. So anytime you scale a picture, not cropping a picture where you're making it smaller in that sense, but when you, like if you took a picture and then you saw it on a billboard, right? It's scaled to where all of its proportions are the same and it still looks the same as the same picture, okay? Or when we get drinks like at a I don't know, McDonald's or somewhere, right? We've scaled the size and the volume of those cups. And any sort of logo, right? Like if you even think about our Mercy Macaulay logo, everything has to be proportional and scaled by the same scale factor in order for like our M's to not look distorted or like the wolf head to not look funny. It all has to be moved by the same scale factor. So in this example, okay, if we had a scale factor of 2, again, we're multiplying by the scale factor. So AB here was 5. When we scale it, 5 times 2 is 10. So our new A prime, B prime would be 10. BC is 3, so 3 times 2 is 6. and 4 times 2 would be 8. Okay. And if we had a scale factor of 1/3, we're going to do the same thing, okay? 6 times 1/3, okay? We're going to multiply across. 6 times 1 is 6. 1 times 3 is 3. 6 divided by 3 is 2. Same thing with 9. 9 over 1 times our 1/3. 9 times 1 is 9. 1 times 3 is 3. 9 divided by 3 is 3. You're probably thinking, Mrs. Duncan, couldn't we have just divided by 3? That's all you did there. And yes, we could have, but I want to note that we can only divide by the denominator there if our numerator is 1. So if it's 1, then yes, we're just dividing by the denominator. But if it was like a 2/3 or I don't know, 5/7, we'd have to take into account that the denominator was something other than 1. Oh, I forgot to label this. There we go. Okay, so now that we can kind of see how to go from here's a scale factor, find our new shape, what happens if we're given the figure and we have to find the scale factor? Okay, so if we're kind of undoing the dilation, right, we're going backwards, we have to think about the dilation as backwards. What did we multiply A, B, C by to get to A prime, B prime, C prime? Okay, so sometimes it's easy to see, sometimes it's not so easy. So like to get from 8, which was AB, to A prime, B prime is 12. Or 6 to 9, 4 to 6. Off the top of my head, I can't think of, like 12 is not a multiple of 8, and 9 is not a multiple of 6. So it might be a little bit harder to see what they are. So if we're going to find our scale factor, we're going to take our image, so the final product, and put it over our pre-image, our starting figure. Okay, and they should all match up. Okay, so we're going to put A prime, B prime over AB, and we get 12 over 8. And then you don't have to write this AB over AB every time if you don't want to. So we'd have B prime C prime is 6 over BC, which was 4. A prime C prime was 9, and AC was 6. So you're probably thinking, Mrs. Duncan, none of those are the same. And that's true because we have to simplify. Okay, so 12 and 8 are both divisible by 4. So if we take a 4 out, we get 3 over 2. 6 and 4 are both divisible by 2. So when we divide a 2 out, we get 3 over 2 again. And 9 and 6 are both divisible by 3. So we divide a 3 and we get 3 over 2 again. So notice these are all the same, which makes sense. We can say that K is 3/2, or if you're not a fraction person, 3/2 is 1.5. If you wanted to simplify it that way, both are, sorry, there's a bug. Both would be correct. Okay, we got to go over one more small thing. Okay, what happens if we have a dilation in the coordinate plane, like in a graph, if we have coordinates? And we're going to do the same exact thing that we were just doing with our segment lengths, if I could talk. We're going to take that scale factor and we're going to multiply it by all the variables. So everything gets multiplied. Okay, so let's look at this first example. Okay, so it says graph the following points and find the image of the polygon after the dilation. Okay, and our scale factor is 2. So I'm going to go ahead and graph the original. So Q, almost graphed R wrong. That's okay. All right, so we have this nice little triangle centered around the origin. Okay, and we're going to start to scale this. Let me do it in a different, let me pick a, I don't know, let's do purple. All right, so again, we're just going to multiply every single coordinate by the scale factor. So -1 times 2 would be -2, and then -2 again, are, okay, so this one might be tricky. 0 times 2 is 0. So that's okay that it's not changing because we're still multiplying. So don't feel like your zeros you have to change. 2 times 2 would be 4. This pesky bug is just... S would be 2 times 2 is 4. 1 times 2 is 2. Got it. No, I didn't. All right, so Q's at -2, -2. R prime 0, 4. S is at 4, 2. Oops. So notice, I just erased all that stuff. The shape itself is staying the same looking triangle. It's just getting slightly bigger, as if we like took all 3 corners and we expanded it. Okay, and that is step 10. So thank you for watching, and next we're going to take a test over all of Unit 2.